Hey guys, today we're going to do day 2 of 11.3. What we're going to be doing today is we're going to be taking all the formulas we learned in the first half of the chapter and we're going to be using them and combining them to find some areas of shapes combined. Okay, as you can look at it here, I've got the first two drawn up here. Okay, the first one kind of almost looks like a picture frame or a border. Okay, because you've got a big rectangle on the outside and then you've got a little rectangle on the inside. For B, you'll notice again you got a big circle on the outside and you've got a square on the inside. So that's what we're going to be working with, is combining 2 or 3 shapes together to be able to get what we need for the area. Again, I have attached the answers because the book does do a lot of this rounding, and actually we're not really going to be using the book for this part much at all. You pretty much will have worksheets for the rest of this chapter, so make sure you're getting those. Again, you're not doing the whole worksheet, so make sure you're double checking that you're doing the correct problems. Okay, whenever we're doing these where they combine more than one shape, what we want to do is we want to start with the biggest shape and work our way down. So in this case, I have the big rectangle, so I want to take the area of the big rectangle minus the area of the small rectangle, and that's the general rule we'll follow. Okay, the big one minus the little one, because the big one would give me all of this, but I want to cut out the middle section. By cutting it out, that's what we're subtracting for. Okay, so for this one, since they're both rectangles, technically it's just going to be base times height minus base times height. Okay, I just got to make sure I do big minus little. So if I look at the big one, okay, my base would be 11, my height would be 8. Minus, if I look at the little one, my base is 9, my height is 6. This one has no square roots or pies. That does make it a little bit easier, so you can just stick it all in the calculator at one time, and you would end up with 34 inches squared. Okay, that would be our answer then. Again, we're going to take big shape minus little shape. Okay, we'll do the same thing over here. This time the circle's the big one. So I'm going to take the area of my circle minus the area of my square because he's the little guy on the inside. Okay, area of a circle is one we just worked on. That's going to be pi r squared. Area of a square is just base times height. Okay, so for this one, the radius, you can see that your diameter is 16, which means my radius would have to be 8. 8 squared gives me 64. Base and height, we don't have those, but we can find those because it is a square. Okay, we do know that it's a 45, 45, 90. Okay, so we can use those 45, 45, 90 patterns to help us find the base and the height. Nice thing is they'll be the same because it is a square. This is my hypotenuse, so I would divide by the square root of 2 to get these two sides. 16 divided by square root of 2 and simplify it will give you 8 square root of 2 for both of these. Okay, so that means I'm going to have 8 square root of 2 times 8 square root of 2. Now, you have to be very careful when simplifying them. This one has a pi, this does not. Okay, so that means I'm just going to leave this as 64 pi. I'm not going to combine it with the others because we can't combine pi's with non-pi's. Careful here when you multiply. Okay, 8 times 8 is 64. Square root of 2 times square root of 2 is just a regular 2. So I end up with 64 times 2, which would give us 128. Again, you cannot combine those together. You do have to leave them separate from each other. So that would just have to be our final answer then. Okay, so again, big shape minus little shape. Really, that's the big idea. It's just kind of combining them and then making sure you can simplify correctly. Okay, knowing when is the correct time to combine things. Okay, when do I need to leave them separate? And remember, you can only combine like terms when you are adding and subtracting. Okay, the next one we've got is a kind of a ring here. So they give you that the whole diameter is 9 centimeters. Okay, they have the outer ring shaded. So we want to take the big minus the little. Okay, so I'm going to do the area of the big circle minus the area of the small circle. Okay, area of a circle we know is pi r squared. So it'll be that same one for both of them since they're both circles. Okay, so if the radius of the big guy, the diameter of it is 9, then that means the radius would have to be 4.5. Now, it's up to you if you want to write that as 9.2 or 4.5, whatever's easier for you to put in the calculator. The final answer will have to be a fraction because it has a pi with it. But if it's easier for you to work this way initially, okay, and then we can go ahead and adjust at the end of the problem. Okay, so that means that this right here would be 4.5. That's for the big circle. Okay, the little circle, you'll notice it gets cut in half again. Okay, so half of 4.5 would give me 2.25 for radius of the little circle. So again, for right now, I can go ahead and put it as a decimal. I will have to change it into a fraction in the calculator. Now you'll notice these both have pi's. If they both have pi's, they're like terms. We can combine them together. So you can take 4.5 squared minus 2.25 squared, change it into a fraction, and you will end up with 243 over 16, and then we'll just attach the pi to it. Again, do not put the pi in the calculator. And that one would be centimeters squared. So again, big minus little. That's really the general idea of what we're doing here. Okay? I'm going to be honest, the next one's a little tricky to draw, so I'm not going to draw the entire thing, but I'll draw enough that we can work through it here. So you've got a square, and then they give you 4 circles that go end to end. That should be a little closer up and down here. Okay, so for this one, your big shape would be the square. So we would do the area of the square minus, the little shapes are circles, and if you count it up, there's 16 of them. Okay, so I need to subtract 16 area of circles because they're all little guys. Okay, we need to subtract all of them. So area of a square would be base times height. Area of a circle would be our pi r squared. Again, there's 16 of them. Okay, they give you that it's 32 on both dimensions. That's how we knew it was a square. So we'll take 32 times 32. And then it's 16 pi. We need radius squared. So we need to find what's the radius of each of these little guys. Okay, well if you look at it, there's 4 of them that go all the way across. So those 4 have to equal 32. So 32 divided by 4 gives me that each diameter is going to be 8. If each diameter is 8, that means each radius would be 4. Okay, so we would end up with 4 squared. Now this does not have a pi, this does, so this will be one that we cannot combine together. We will have to keep them separate. Okay, 32 times 32 will give you 1024. And then you end up taking 16 times 4 squared, which is another 16, which will give us 256. And then you just want to attach the pi to that at the end. All right? So again, just big minus little. If there happens to be more than one of them, that's fine. Okay, you can still work with it. All right, next one. All right, so for this one, some of you might be tempted to say that your big shape is a circle. You would kind of be correct. However, I want to just focus on this part of the circle. Okay, because you'll notice these two are different than these two. I only want to focus on the ones where there's shading. Okay, if you look at just this slice of the pie or the slice of the pizza, that's actually a sector. Okay, so instead of using the full circle, I'm going to focus on the sectors. Now you'll notice there are 2 of them, and they are congruent to each other because they both have the 90-degree angle. Okay, so I'm going to do 2 area of sectors because again, there's 2 of them. Minus, we need to take away these right triangles. Again, there's 2 of those, so it would be 2 area of the triangle. Okay, so again, using the sector, not the full circle, because again, the sectors are set up differently for this one. Okay, so area of a sector is x over 360 times the pi r squared. Area of a triangle is half base height. This time I did keep the 2 on the outside. For me, it just helps because these formulas have a little more to them to kind of keep things separate. Okay, so let's go ahead and plug in our pieces. Okay, we know that this measurement is going to be 90 because if the central angle is 90, then so is the arc. And our radius is 6, so I'm going to have this 36. Or you can write that as 6 squared if you want, that's fine. On this guy, luckily our triangles are right triangles, because if they're right triangles, that's a radius. This has to be the same, and then it'd be the same for these as well. So our base and height will just both end up being 6. Again, this has a pi, this does not, so do not combine these all together. Just work them each out separately. Okay, so I would take 2 times 90 over 360 times the 36. That will end up giving you 18, and then just attach the pi. If you look here, the 2 1/2 actually cancel out, so you just end up with 36 for that one. Okay, so again, area of sector minus area of triangle for that one. All right, 2 more of them here. Oops, again, those should be attached to each other. All right, so for this one, if you notice your big shape, if you were to kind of continue it here, excuse me, would be a rectangle. So we want to take the area of the rectangle, and then minus, we want to take basically this bite out here, which is a semicircle. Okay, so area of a semicircle, okay, would just be 1/2 the area of a full circle. Okay, you also could have used your sector equation there. That would have worked as well. And then it just would end up being 180 over 360, but that becomes 1/2. So I think it's a little bit easier to do the semicircle here. Okay, so area of a rectangle is base times height. And then we got 1/2 pi r squared for the circle. So our base and height are 6 and 13. Now we have to find the radius. Well, notice if it's a rectangle, if this is 6, which means my full diameter would be 6, which means my radius would be 3. Okay, 3 squared will end up giving us a 9 pi. This one does not have a pi, this one does, so again, do not combine those 2 together, do keep them separate. So I'll end up with 78 minus 9 over 2 pi. Again, must be a fraction with the pi's, cannot be decimals, and that would be yards squared. All right. And then we got one last one. If you want to, I usually have you guys do this one in class by yourself, and then we check it together. So if you want to pause the video and try and see if you can do it yourself and then check, it would be a really good idea. Okay, but I'll leave that up to you for this one. Okay, so for this one, your big shape is going to be the rectangle, and your little shape is going to be the circle. Okay, so we'll take the area of the rectangle, which would be base times height, and the area of your circle would be pi r squared. So the base and height on this one that they give you are 15 and 6. You need to find the radius of the circle. You'll notice the circle fits perfectly if we go this direction. Okay, which means if that's 6, my diameter has to be 6. Okay, which would make my radius 3. 3 squared would give us 9. Do not combine those 2 together, so you'll end up with 90 minus 9